In today's session, we are discussing about how an instruction is executing inside the system, or which all are the registers or which all are the paths that instruction is going through inside the processor and from the input unit to the complete execution. So that is what we are discussing. So first of all, what do you mean by an instruction? The instruction is a command we are giving to the processor for doing a specific task. So what all are the types of tasks and processor is doing for us? The processor is doing mainly three types of tasks. One is data transfer, that is within the computer. That means within the computer already we know about the different functional units of a computer. So it may be from any two internal functional units inside the computer. That may be either memory to ALU or maybe from the input unit to memory, or maybe it will be from the memory to ALU or ALU to memory. So whatever it is, that is one is data transfer within the computer, and second one is from the input device to computer. That is like whatever I am typing in the keyboard or whatever I am giving through the voice command or whatever I am giving through mouse. So that is from an external world, it is giving input to the computing system. That is the second type of data transfer. And third one, as you know, it is arithmetical and logical operations. So these are the type of instructions present inside the system, and that will be these are the works the processor will be doing for us. So three types of instructions are there. We will discuss in the types of instructions and all minute details later. Now an overall idea only will be giving. So three types of instructions are there. So that you know what is a program. Program is a sequence of instructions for performing a specific task. And where these instructions will be storing? Already when we discussed about the structure of memory, we have discussed that, okay, two types of things will be storing in memory. One is instruction and second one is data. So our instructions, a set of instructions, what is there in the program, that complete instruction will be storing inside the memory. So whenever the processor wants a particular instruction to execute, processor will give the address of that corresponding instruction to memory unit, and then it is reading that corresponding instruction from the memory unit, and that will be executing by ALU. So the processor will be reading that instruction from the memory is also called as fetching the instruction. Both are same. Reading the instruction from the memory is also called as fetching the instruction. So processor fetches that instruction and make up the program from the memory, and then it is processing that corresponding instruction. So this is the basic steps involving, and when we have discussed about the structure of the processor, we were showing about a lot of other registers. Now we will see what is the relevance of those registers and where we are using it. Now, how a typical instruction will look like. Here we are in the complete syllabus, we are discussing only about assembly level programming language, not about the programming language what you are familiar. So it is all about assembly level programming language. See, this is an example of assembly level programming language. You understood what is this instruction is doing? So every instruction will be having two different parts. It was written like add location A. Log A is representing location A. So that is just an address, comma R0. R0 is what? When we discussed about the structure of the processor, we were mentioned that there are a lot of memory units which are residing inside the processor. That type of memory is called as registers. So R0 is one of the general purpose registers. You will be having n number of registers present in the processor, and R0 is one of the register present inside the processor. So add location A, R0 is an instruction, and that instruction will be having, every instruction will be having two different parts. One is opcode and second one is operand. Opcode means what is the operation it is asking the instruction to do. The instruction or operation is addition. So opcode is add. And what is the operands, what all are the operands or data present in the inside the instruction? That is the location A and R0. So location A is one address like 2000, 3000 some address. So the content inside that 2000 is one operand and content inside R0 is another operand. So the every instruction will be having two parts. One is operand and another one is opcode. Opcode is mentioning like what operation the instruction is performing, and the second operand will be telling where that operation is performing. Okay. Next thing is actually what this instruction will do. That is what the thing. What if I execute this corresponding instruction, add location A comma R0, what exactly this instruction will do? The instruction will be doing a task. Anyway, it is addition that I understood. And the location A, I already told you, certain content will be there in my location A. And after that, I am checking what is the content of R0. Again, one more R0 is there. Okay. And I should take the data present or in both the memory location and I should add that much I understood. But where I will store it, the resultant value of this one, whether I am storing in location A or R0. The instruction is like you add location A content and R0 and the result you should store in R0. The result you should store in R0. This is what this corresponding instruction is doing. So location A content will be added with R0 and the result will be storing into R0. So whatever be the initial value of location A, assuming that it was 10 and this was 20. So after executing the instruction, location A content will be preserved, that is not changing, but R0 content will be changing to 20 plus 10, 30. So the R0 content will be changing to 30 and location A content will be preserving and it is performing the addition operation. So that is what the thing I have mentioned. The square bracket is representing the content. So it was mentioning like the content inside the location A, and what is square bracket of R0 is indicating the content inside R0. Both will be added and the result will be storing into R0. Clear? Okay. What all are the difficult things for the processor? Anyway, who will perform the add operation? Who will perform the add operation? At the end, I will ask a question, so please listen. Add operation will be performing by the processor. So processor will be having, processor can access the data which is residing in R0 immediately because the processor is already the data residing in the R0 because see this is the ALU is performing the data. So whatever the data present in R0 ALU can take immediately. But whatever the data present in this memory that is difficult for processor to take it all the time. So what it will do is it will first take the memory things, that is location A content. I told it is some address. So example it is 2000. From 2000 that corresponding data will be taken and it will be storing in R1 register. And so one operand will be available in R1 and second operand already it is present in R0. So both R1 and R0 is easily accessible for ALU. So it will take the data from R0 and R1 and it will process the result and the result will be writing back to R0. So even though it was written as a single statement, this location A loading part, that means it is an external memory. It is the internal memory what was present inside the system but not inside the processor. So those data from the memory unit to processor, that transfer is happening through the instruction load location A comma R1. So what is happening? Load is the instruction which was taking the content of location A and it will be keeping in R1. My ALU can take the data from R1 and R0 immediately because it is present inside the processor. So R1 and R2 ALU can take immediately. So what I am doing from location A, the content will be transferring to R1 and then R1 and R0 has processed in the ALU and the result will be writing into R0. Whose content will be overwritten? That is whether R1 or R0 or location A. When I am executing this instruction, add location A, R0, whose content will be overwriting? Whose content will be overwriting? Hello?
Ma'am,
Hello?
R0.
Correct. The content of R0 will be overwriting. Okay, that is the details regarding the typical instruction. Then we'll move on to the next part. So this is the complete structure of the processor. Already you know that memory unit is outside the processor, and other than that, inside the processor you are having different registers like MAR, MDR, PC, IR, and the general purpose registers, ALU, and control unit. This diagram so many times you have seen, but again, this is very, very important. You should study this diagram. So already you familiar with this memory and this general purpose registers that I already told you, where you can already take the data from there. So this is called a general purpose registers. So for every, I told intermediate result and all, ALU can store in the register. So that is for all the operands will be available in the register. So immediately ALU can take that. Control unit also we have discussed, and ALU also we have discussed. Now we should discuss about the other registers present inside the processor. So we'll see what all are the other registers and where we can use these registers. So the registers are, one is IR. IR is representing, it is very, very important. All of you please listen. IR register is instruction register. IR register is instruction register, that you should remember also. IR register, don't give any other expansion. Usually I am seeing on paper like some other expansion you will be writing. Instruction register is IR. Then PC is representing the program counter. Then R0 to Rn-1 n general purpose registers are there. And after that, MAR is representing memory address register. So MDR is representing, next is MDR is representing memory data register. So these are the expansion. So MAR is representing memory address register. So it is a register, and what will be the content of that register? MAR? Definitely it will be an address. So MDR is representing memory data register. What will be the content of that? That will be data. And other than that, you can have a general purpose register for storing the operands. And next is program counter. Counter means what? Counting the number of instructions. So program counter is actually a register which will be storing the address of the next instruction to be executed. Which will be the next instruction immediately? If the current instruction is processing is over, which is the next instruction the processor should take? And that instruction's address will be storing in the program counter. Are you clear? Program counter means the address of the next instruction will be storing inside the program counter. So we have studied about two registers. One is program counter and a memory address register. Both will be storing an address. That part at least you should remember. So which all are the registers will be storing address? One is program counter and the second one is memory address register. And the next one is instruction register. So instruction register is representing like a, what is the use of this instruction register? Instruction register is, anyway, it is a register, and what will be the content inside that? The currently executing instruction will be the content of the instruction register. So what is this IR? IR is representing instruction register. So what is the content of IR? That is the currently executing instruction will be storing in IR. What is program counter? Program counter will be address of the next instruction to be executed. MAR is what? The memory address register. It is keeping an address. And what is MDR? MDR is the memory data register, which you will be keeping the data part needed for ALU. And even you are having different general purpose registers of n number general purpose registers is there that will be storing the operands. Okay, so that are the registers present inside the processor. USN 168 what are the different registers present inside the processor? Tell me. USN 168. One 68 is absent then. 169.
Yes, ma'am.
Tell me what all are the registers present inside the processor?
Instruction register, program counter,
Hmm.
general purpose register,
Hmm.
memory address register, and memory data register.
Okay, fine. So what all are the registers? 170. What all are the registers which will be storing address as a content inside the register? USN 170.
Uh, Program counter and memory address register.
Very good. Okay. Okay, we'll proceed. So these are the registers present inside the memory, and I told you what are the purpose of these registers. Okay. Next thing is, again that same thing only has written. You can, if whoever was not listened the session, please listen now at least. Two registers will be there. So one is called a MAR, that is called memory address register, and memory data register. So memory address register is keeping address and memory data register is keeping data. So MAR holds the address and MDR holds the data. Instruction register holds the instruction that is currently being executed. So currently executing instruction will be storing in the instruction register. What is program counter? Points to the address. It is pointing to an address of the next instruction that is to be fetched from the memory. So program counter is having an address of the next instruction that is to be fetched from the memory. So these are the registers present. Now we'll see the flow of execution of the instruction. So now we'll see the flow of execution of the instruction. Okay, I will show the slide after the explanation. So first, anyway, where will be our instruction now? We will be keeping the program. Where it will be keeping inside that? It is present in the memory unit. It is present in the memory unit. We know that it is having a memory unit, and from that memory unit, the instruction should come to your ALU. So this is the memory unit. So this is the memory unit. From the memory unit, the instruction should come to ALU. But before that, the ALU should tell to the processor memory unit that where is the instruction is residing. How ALU will be or processor will be giving the instruction to the memory unit. It will tell the address of the. It will tell the address of the instruction. It will tell the address of the instruction where it was present in the memory. So it will be, for example, it is giving a 2000 as the address. So that address has transferred from where to where? 2000 is the address that will be transferring from the processor to memory unit, so that memory unit will fetch that corresponding instruction and it will be transferring to ALU for execution. So that is the complete overview. So we'll try to see what all are the steps involved. So already we are assuming that the input has given from the input device and it is stored in the memory. So your instruction is already stored in the memory. Now from memory to processor, how it is taking and how the result of the processing result will be storing again back to the memory. That is the instruction operating steps we are discussing now. So in the beginning, the data or instruction is present in the memory. Next, initially your program counter. What is program counter? Which is the next instruction the processor should execute, that will be decided by whom? The program counter register. So initially your program counter will be starting with the address of the first instruction. So program counter is initially will be having a value that is 2000. That was the initial starting address of the program. So that will be the content of your program counter. So program counter is having 2000 as the address. So program counter is keeping the first instruction's address into it in the beginning. After that, after execution of the first instruction, the program counter will be increasing to the next immediate value, that is 2000. If one instruction is taking 4 bytes, it will be incrementing to 2004, or one instruction is taking 1 byte, then it is increasing to 2001. So that details we'll see. Anyway, it will move to the next instruction. That much you should understand. So in the beginning, program counter is having the address of the first instruction of your program. After that, what will happen? The contents of this flow, you should remember, the contents of program counter will be transferred to MAR. I told 2 registers will also keeping which one? Address only will it be keeping. So which is the instruction the processor should execute that was initially present in program counter. Now that value will be transferred to MAR. MAR is memory address register. So it is transferring to memory address register. That is the first flow. So initially program was there in the memory. Your first instruction's address is stored in the program counter, and that address is transferred to MAR, that is the memory address register. After that, what will happen? After that, whether into that corresponding memory, for example, 2000 is the memory you are having. Into that memory, whether I should write some content or whether I should read the content of that corresponding memory, that information who will provide? What is the operation I should do and when it should perform? Which unit will be giving that instruction? Which functional unit will be giving the instruction for controlling
Control
what?
unit.
Very good. Control unit will be giving the instruction for reading the instruction or writing into the instruction. So once the address is loaded in MAR, the control unit will give a read signal, so that what is the next thing it should happen? It should read that corresponding thing. So that is the next thing. So once the program counter content is transferred to MAR, the control signal will generate a read signal and it will send to memory. So that memory unit will get to know that, okay, this is the value, whatever is residing in 2000 or what is the content of MAR, that corresponding address value I should give to processor. And first instruction is read out and loaded into MDR. So that instruction, so the memory unit understood that, okay, the value present in the 2000 memory location, that I should transfer back to processor. So in processor way to where I should give, whether it is directly giving to ALU or not, no, that is a data. Actually, the memory will be having an instruction as well as data, so that the instruction will be coming from the memory and it will be storing in the next register what we are having, that is called the MDR, that is memory data register. Now which data I have fetched from the memory? That instruction itself I have fetched from the memory. So that is a data. So that data I am storing in MDR. I told you now that instruction I should execute. So before executing that instruction, I should also make sure that what is IR? IR is the instruction register. The currently executing instruction should be there in your IR register. So what it will do? What should be the next thing? Now the instruction, whatever is fetched from the memory unit, is present in where? In the MDR. Now I should transfer that instruction into IR register also, because the currently executing instruction is present in the instruction register. I think this is the first set of flows. So at least the instruction we have read from the memory and it has currently available inside the processor. Till now I didn't start executing the program, but this is the initial set of steps. So I will tell you one more time. The program will be there in the memory unit. First I should fetch that corresponding memory address instruction. Assume that my instruction is present in 2000. So the first instruction I should fetch from the memory. The first instruction's address will be storing in program counter. That is the initialization part. Once it was loaded with the program counter, that data will be transferring to your MAR, that is your memory address register. And so that register will be, memory address register content will be transferring to memory unit. So it will get to know what is the address, but whether I should write it to there or I should read from there, the memory unit don't know. So control unit will generate the corresponding signal for that. It will generate a read signal. So memory unit understood that, okay, in this corresponding particular memory location's content it should read. Once that instruction is fetched from the memory, it will be storing inside the processor. And where it will be storing? For that we are having another register called memory data register. So that data register that is currently executing instruction, that should available also in the instruction register. So the MDR content will be again copying into IR register. So this is the initial part. After that, what will happen? Now the instruction present in IR register, I should decode that. Who should decode? Processor should decode and execute. Decode means what? What is the operation it is doing and where is the operands present. We know that every instruction will be having two parts. What is the, one is opcode. Opcode will be telling about what is the operation I should perform, and operand will be telling where is the data present inside that. So that decode and execution part will be performing in the next step. So what will happen in the decode? Instruction present in, now I have taken the data from memory unit and it is available in my IR register. I am trying to decode it. Decode it by the processor and understand what operation it has to perform. While when it is loaded into IR register itself, already one instruction I have fetched from the memory. Immediately your program counter will be increasing by 1. So it means that it is just next to immediate instruction, it is pointing to the next immediate instruction. So it is incrementing. What is the content of program counter? Initially it was 2000. Now once the 2000 content, once it fetches to the processor, program counter will be increasing to 2001. That is the next instruction where the program counter is having. So the next instruction's address will be loaded with the program counter with the 2001. That is the next step of instruction. After that, if the data required in the operation is available in the register, then it performs the operation. For example, if the initial instruction, whatever was I have shown, is like add R0, R1. If this was the instruction, both R0 and R1 is available inside the processor. There is no need for fetching anything from the memory, so that immediately the ALU can perform the operation. That was the next statement. If the data required for operation, what is the data required for the operation? That is the operands of the instruction R0 and R1. If R0 and R1 is present inside the instruction, then if both are present inside the processor itself, then there is no need of fetching any data from the memory. Immediately the processor can do the operation. If the data is present in the memory, for example, instead of R1, instead of R0, whether the data was present like add, the instruction what I have shown before, like add location A, R0. In this case, what will happen? Location A, R0, if this is the instruction I am having, in that time, location A is in the memory unit. That is not present inside the processor. R0, R1, R2, all those general purpose registers and all available inside the processor. But location A is coming from the memory unit. So what should I do? I should go to this location A address in the memory, and again what is the operand present inside that location I should fetch and I should take it into the processor. So that is the part. Are you clear with what I am telling? Are you getting it?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
So R0 and R1 are the operands present inside the instruction, means both will be present inside the processor. So processor can directly execute that instruction. But instead of that, if location A or any particular location, for example 3000 is the location I am giving. So in that time I should fetch the data present in 3000, and that should extract from the memory unit, and I should keep it in any of the general purpose register. So that operation is pending. That is the next point is telling, if data is present in the memory, then some other set of things I should do for fetching the data from the memory to the processor. So what are the things is doing? So I should know where is the data is residing. That is, I already told in my example, that is present in the location A. Location A itself is an address. So I mentioned that it is 3000. So the address of data will be there. Which register can hold the address? MAR only. Only we are having only one register for holding the address of the data. The program counter is already having the value 2001. That is the next instruction it should fetch. So the program counter is already having the value. Its purpose is some other thing. It's not for transferring an address. Its program counter is just for tracking which is the next instruction should execute. So the address of data what I required is my location A, that is 3000. So that I will be transferring to MAR. Once it will get into MAR, that will be anyway memory unit will get it, and that will keep in which bus, through address bus it will connect to the memory unit. After that, so memory unit understood that okay, this is the address, 3000 is the address, that much memory unit understood. But what operation, again memory unit don't know whether I should write into 3000 or I should read from 3000. So that time again the control unit will issue the read signal. So once the 3000 data is fetching from the memory, it will be storing to which register? Already in the same story we have told for instruction. Now the data I am checking. So in 3000 memory location, the value was present is 5. Assume that the value present in 3000 memory location was 5. So that data will be taken and it will be storing in which register? When you fetch the instruction from the memory, it was stored in which register? See, when you first the instruction and read out and loaded into which register?
Memory data register.
Memory data register. In the same way, if you fetch the value present in a particular memory location, for example 3000, that will be loaded into which register? MDR only. It will be loading into MDR. So MDR is present inside the processor. So from memory to processor, that transfer has over. Then few set of ALU can take data directly from MDR. Directly ALU can take the data from MDR, but few set of processor, the data should be always available in the general purpose registers. So such type of things, from MDR the data will be placing into any of the general purpose registers. So from MDR data can be directly routed into ALU, or it can be placed in the general purpose registers and the operation can be performed. So the operation is performing inside the ALU. Again the result I should write into the register or even into the memory. The result of the operation can be directed towards the memory or into the registers. Okay. So how can it write the result into the memory? What all are the things? Now where is the data? Data will be processed in the ALU and the result is available and it was written into R0. And after that, if it wants to write into a particular memory location, that address the processor should give it to MAR, and MAR will give that address into the memory unit. But after that, the control unit should issue a write signal, and then that time the data present in R0 will be copying into the corresponding memory location. So result part is result of the operation can be directly write into either register or the memory. So this is all about the execution sequence of the instruction. One more time I will tell. So at least now everyone please listen. So this is the complete structure of the system. So we will have a memory unit, input output unit, and a processor. So you are having memory unit means it is for storing the data, and you instead of taking the data from the memory unit to ALU, actually we are memory unit to ALU. We are having a set of other set of registers which is residing inside the memory also. So what is the thing it will be doing? The first instruction address will be storing in ALU. From there it will be starting. We are assuming that the instruction is present inside the memory. So instruction is present inside the memory. So the address, the CPU, the processor will be loading into the program counter. So what is the where the instruction is residing? That address will be storing in the program counter, assuming that it is in 2000. So program counter is having the value 2000, that will be loaded into MAR. MAR is memory address register. So it will be loading into MAR, and that address will be communicating with the memory unit. When the memory unit is knows that corresponding address, the control unit will also generate a read signal, so that the memory unit understood that from this 2000, that I should read the data and I should give back to processor unit. So the instruction present in the 2000 memory location will be fetched from the memory, and it is storing into MDR. So the data will be storing in MDR, and that data is the instruction present in 2000 memory location, and that complete instruction will be copying into IR register. That is the instruction register, because the currently executing instruction should be there in the instruction register. In the same time, the program counter has already fetched the instruction in the 2000. So the next immediate value will be, the program counter will be increased by 1 to, and so it will be pointing to 2001. 2001. Now the instruction is available in IR register. I should decode and execute the instruction in the IR register. How can I decode and execute the instruction in the IR register? For that, first it will be checking what is the operation it should do. That is performing by the that will be getting from the opcode, and what is the operands. If both the operands or all the operands of the instruction are present in the general purpose register, ALU can directly perform the operation. But if any of the operand is present in the memory, that time ALU should again generate the address of the operand, and it will be keeping in the MAR, and MAR will be keeping the data transferring through the address bus to memory, and the control unit should also generate a read signal, and then that data will be taken from the memory, and again it is storing into MDR, and that MDR some cases directly can ALU can take data directly from MDR, or some cases it will be transferring to the general purpose register, and then from the general purpose register it is taking the content, and after the calculation the result will be again right back to the general purpose register, or even through the memory. For that, control unit again should generate the write signal, and also the ALU should specify where it should write the content. For that, again MAR will be using. So the first part, result part, you can just leave because it was not clearly mentioned in the text. What they are expecting is the result can write into the registers. So up to that, anyway, I think everyone is clear. Program counter will have the first instruction. That address will be storing first instruction's address. That will be storing in MAR. That will be given to memory unit, and in the same time, control unit will be generating a read signal, and it will be fetching the data, storing in MDR, and it is transferring to IR. IR will be having the current instruction that will be decoding and executing. When the instruction is having all the operands in the general purpose register, direct execution by ALU. If anyone is not there, any of the operand is not there in the general purpose register, if it is there in the memory, again that data address will be keeping in MAR, read signal will be generating, fetching the data to MDR and transferring to general purpose register, and ALU will be again executing the instruction, and result will be storing into general purpose register. This is the complete operation. Okay, so I will show a video related to that. Maybe that will give you a clear idea. And what we will discuss in our next class is how can you measure the performance of a computer. How can you tell that this computer is better than some other computer? How can you compare the performance of two computers? So that is what we'll be discussing in the next session. Any doubts?
Y and store the result in Z. If I was going to write something similar in an assembly language, I would need more commands. I need to think about the accumulator. So what we're saying here is load the contents of memory location 10 into the accumulator. Add the contents of memory location 11 to whatever's in the accumulator, and then store whatever's in the accumulator back into location 12. Referring to memory addresses by numbers is called direct addressing. Some assembly languages will allow you to use what's called symbolic addresses. So for example, I might say load X, add Y, store Z. That depends on the language. Once my assembly language source code has been turned into machine code, specifically once it's been assembled, it might look something more like this. You can see here we're using 6 bits for the operation code and 10 bits for the operand address. You might find something like this in a very old 16-bit machine. Now let's think about the registers inside the CPU. The blue box shows the CPU, and we can see inside there we've got a control unit, we have the accumulator, and the arithmetic and logic unit. We've also got
Accumulator is also a register present inside the processor. You can just imagine that as general purpose register. Okay. Now you imagine it as general purpose register because our textbook was mentioning it as general purpose thing, general purpose register. So the example, instead of general accumulator, you can think like it is general purpose register.
got some other registers, the program counter, the current instruction register, the memory address register, and the memory data register. And we're going to take a look at how these different registers cooperate to run the program. You can see on the right hand side I've got the memory, and the program has already been stored in memory. Now I think we need to take a reality check at this stage. First of all, the accumulator is actually a register which is part of the arithmetic and logic unit. But for the purposes of this demonstration, we've separated them. Secondly, the program wouldn't be stored as assembly code as shown here. It would be the machine code that's inside the RAM. The memory addresses themselves would also be in binary. And to tell you the truth, we'd be numbering from the bottom up. But for the sake of this presentation, we've distorted the reality a little bit. So what happens when a program runs? To begin with, the program counter stores the address of the next instruction to be fetched. In this case, the first instruction, which you can see is in memory location 100. Before we can fetch the instruction from the RAM, that memory address has to be placed into the memory address register. Once this has happened, the contents of that memory address can then be loaded into the memory data register. So we're fetching the first instruction now. Next, that instruction needs to be placed inside the current instruction register. Once it's been fetched into the current instruction register, the program counter will increment by 1. So the program counter is always pointing to the memory address of the next instruction to be fetched before we've even executed this one. Now we can decode the instruction. And without going into detail, the control unit comes into play and it opens various pathways. The next stage in the process is to execute that instruction. The instruction is load 10. In other words, load the contents of memory address 10. So we're going to fetch something from memory address 10. So memory address location 10 now goes into the memory address register. Then we can take the contents of memory location 10 and place that into the memory data register, overwriting its previous contents. And then the contents of that memory address can be placed into the accumulator. That's the first instruction executed. Now we're going to fetch the next instruction. The program counter is already pointing to the memory address of the next instruction, so that memory address can be copied from the program counter into the memory address register. We can then take the contents of that memory location and put it into the memory data register. Now it will move into the current instruction register, ready to be decoded. But before we do that, we increment the program counter, so it's pointing to the next instruction. Okay, so it's time to decode this instruction. So add 11 is passed to the control unit, various pathways are opened, and the control unit makes sense of the instruction. So this instruction says add the contents of memory location 11 to whatever's in the accumulator. So this is where the arithmetic and logic unit really comes into play. An add instruction is passed to the ALU. The contents of the accumulator are moved to another place ready to be worked with. Now we can get the contents of memory location 11, and because we're going to fetch something from the memory, that memory address has to be placed into the memory address register. Once that's happened, we can get the contents of that memory location and place it into the memory data register. You're probably starting to see what the memory address register and the memory data register do. Whenever we want to get something from the RAM, or move something into the RAM, as we'll see in a moment, we must put its memory address into the memory address register. Whenever data, or a program instruction, moves to or from the RAM, it goes via the memory data register. So we have our number 3. That gets placed into the accumulator, and then the arithmetic and logic unit will add that to the 2 that we originally had and place the result back into the accumulator. So we're keeping a running total. It's accumulating the result. It might be worth mentioning at this stage that the circuits inside the arithmetic and logic unit are called adder circuits. They're actually very simple. The truth is, a computer is just a very sophisticated adding machine. Okay, so now we're ready to get the next instruction, which is in location 102. So the memory location 102 is copied into the memory address register. The contents of that memory location, in this case the last instruction, are copied into the memory data register. This instruction moves into the current instruction register. You can probably see what's going to happen next. We increment the program counter. We would probably have a stop or a halt instruction in that position. Now we can decode that instruction, which basically says store the result in the accumulator back into location 12. We're going to put something into location 12, so that memory address must be put into the memory address register, and the contents of the accumulator move via the memory data register into that memory location. And that's our program complete.